Here's 2.3 postulates and diagrams. So this one is going to be a lot of just words and definitions. So buckle in and let's get going. All right, here's 2.1, postulate 2.1, 2-point postulate. So what this is through any 2 points, there exists exactly one line. So here I've got my 2 points, G and J, and because there's 2 points, there exists a line between these 2 points. I'm going to label this line B. All right. Next, we have 2.2 line point postulate. And this is basically saying the opposite of what 2.1 says. It says any line contains at least 2 points. So, because here's a line, I'm going to label 2 points on my line. We're going to label these, let's see, what's one that never gets used? Q. And I feel like no one ever uses a V. All right. 2.3 line intersection postulate. So if two lines intersect, then their intersection is exactly 1 point. So here's my two lines, M and N, and they intersect right here at this point. This will be point, let's go with, how about I? I'm going to make that a better I here. I for intersection. All right. 2.4. Through any 3 non-collinear points, there exists exactly one plane. So we're going to draw here 3 non-collinear points. So here's my one, that's D. Here's another point, E. And I'm going to do another one over here. We'll label that one F. So any 3 planes, bam, or any 3 points, bam, I have my plane. Alrighty, let's go on to the next one. 2.5, a plane contains at least 3 non-collinear points. So again, here's my plane R, and once again I have D, I have E, and I have F. So because I have a plane, I have at least 3 non-collinear points. I could have more. I could have 6, 12, 25, but we're just going to go with 3. 2.6, the plane line postulate. If 2 points lie on a plane, then the line containing them lies in the plane. So here's my 2 points D and E. Now these 2 points lie on this plane. They're on plane R. So because they lie on the plane, the line containing D and E, we'll label this line M. Line M now also is on plane R. 2.7, I was not able to draw, so I just picked a picture off of Google. But if you're able to replicate this, fantastic. That is, if 2 lines or 2 planes intersect, so we have the blue plane and the green plane, then their intersection is a line, and you can see that line right there. That's the red line. All right, so let's see if we can use these and do some examples. All right, so here's our examples. Example 1, they want us to state the postulate illustrated by the diagram. So this is the one where it says, hey, here's 2 lines, they intersect, and they intersect right here at this point. So let's see, that one would be our 2 lines intersect at a point, 2.3. Okay, and then I'm just going to briefly state what that says. 2 lines intersect at a point. All right. This one would be the diagram that I just could not draw, and that would be 2 planes intersect at a line. That's going to be 2.7. I'm just going to, again, just briefly draw it over here. 2 planes intersect at a line. All right. Example 2. Use the diagram to write out to write examples of the plane point postulate and the plane line postulate. So the plane point postulate says that a plane contains at least 3 non-collinear points. So let's do plane point here. I'm going to label it as PP. Okay, so my examples of my PP, again, the plane point postulate says that a plane contains at least 3 non-collinear points. So we have to use this to identify 3 non-collinear points. So that would be on this plane P here. We have A, B, and C. Points A, B, and C. All right, so now let's look at what the plane line postulate says. The plane line postulate says that if 2 points lie on a plane, then exactly 1 line containing those 2 points lies on the plane. So this one again is going to be talking about points B and A. Because points B and A lie on plane P right there, then line N also lies on the plane. Beautiful. Example 3. Which of the following statements cannot be assumed from the diagram? All right, so let's take this one by one. So point A, B, and F, so let's highlight those. Here's A, B, and F, so that's a straight line all on plane P. A, B, and F are collinear. They are on the line. I would assume that those would be collinear. So yep, I would say that one is good to go. Points E, B, and D, so again, let's highlight those. E, B, and D are collinear. Well, there's not a line going through them, so because there is no line going through them, we cannot assume that they are collinear. Line AB is perpendicular to plane S. So here is line AB. And is it perpendicular to this plane right here? Now, if you notice right here, that is the symbol for a right angle. So because that symbol is there, this one is able to be allowed. Is CD, so let's erase that again. Is line CD, that's right here, perpendicular to plane T? And there's plane T. So because we know that CD is on plane S and plane T is perpendicular to plane S, then we could say that CD is perpendicular to plane T. All right, last one. Is AF intersects BC at point B? So let's find AF. Here is AF. Does AF intersect BC at point B? Looks like it to me. And there's that point of intersection. Alrighty. That concludes today's notes. Please go ahead and do the assignment listed above. If you've got any questions, please let me know, and we can go over them. Have a great day.